Okay, I'm going to come around, see how you made out with that U substitution with the power rule and the ln. While I'm doing that, I need you guys, and try to do this without using your notes. Let's see how much you know. If you have to use your notes, then fine. But I want you to go and write down the 6 trig integration formulas, not the inverse trig, like the regular ones. Like, give me an example of one. The antiderivative of cosine x with equals sine x plus c, right? So there's 6 of those. See how many you got. Because today, we're going to use U substitution using those integration formulas. All right. Okay, so the way we're going to play this, someone's going to volunteer to give one of them, and then that person is going to call on someone else to give the next one. All right, Jillian, I'm going to let you because you gave me that one before, so you can start it going. Okay, now call on someone else. You don't know. You don't know. You got 5 of them. Give me one of them. Well, do we want to give Riley a break and go to Sydney? No, we should just stay with him. All right, Sydney. No one's just making these up. These are Riley. You need to focus here. All right. There's no way that you think people are just making stuff up. The first half of the year we learned derivatives. Then we worked them all backwards. Jan.
No one ever picks on Jan.
I can't believe we just recorded Big S. Okay, Jen. Equals what? I'm sorry. Beautiful. All right, it's up to you. You can call on anyone you want. Olivia. Nice. Good job. Who do you think, Olivia? Who's getting it? Oh. We have no flexibility. Wait. If Jacqueline wants to call on you, she'll call on you. Well, that's not one of them, but cosecant cotan is. Okay, I'm taking that one. Equals. Good. All right. Negative cosecant x plus c. All right, who's the last person? All right, Jess. You're on. Uh-huh. All right. Yeah, picking on Riley there, that just threw everything off. Okay. Okay, today, when we do U substitution, after we go over the homework, we're going to wind up with one of these. In other words, we're going to make a little U substitution. We'll wind up with something like the integral of cosine u du. So you have to know that it equals sine u plus c. Or if you wind up with the antiderivative of secant u tan u du, you have to know that equals secant u plus c. All right? So you got to know these formulas, or you're going to switch it over and you won't know what to do. All right, let's go over the homework. Now, I gave you the answers on the back of this summary when I was walking around the room. Did I give one to everyone? Someone say no? Come on up, I'm attached. That's right. All right? Yeah, you can blame me for that one. Okay, so check your answers, pick ones, we'll go over some. I heard 3 so far. 5. 3 is the only one you got right. You want to do 1? Okay. All right, I have one right here. Let's start with this one. You ready, guys? You ready to focus? I'll wait for you. Are you focusing? I can tell you're not. Oh, man. All right. First thing you want to do is if there's a constant multiplier, just pull it right out front. It just makes things look nicer. So I'm pulling the 24 out. And I have x cubed 3x to the 4th plus 4 to the 4th dx. Constant multipliers, you can always just get them out of there. Now you look at this and you ask yourself, what are you going to make u? What do you think? What's inside here, right? So we're going to let u equal 3x to the 4th plus 4. What do you got to get after you get u? Do you remember? Du. And you get du dx, and then you can get du from that. And you have to take the derivative to go from u to du. And so what would that be? Yes, excellent. Now, what is so important is that you have in your integrand every factor of du, okay, of du. You don't care about u right now. Well, you have to make sure that you have the dx, the x cubed, and the 12. So you look at your problem there, and you check it off. Is there anything you're missing? The 12. You say that, guys, you have the dx, you got the x cubed, you're just missing the 12. So you can put the 12 in anywhere between the integral sign and the dx. I don't care where it is, because it's all multiplication, it's commutative. I'm going to stick it in right here. Now, I just put a number in, I multiplied by 12, and it wasn't there before. I do not want to change the problem. So what do I have to do on the outside? Multiply by the reciprocal or divide by 12. Now we're going to make it look easy and lovely. What number do we have out front? 2. We are going to convert, I don't like the way that looks. We're going to convert everything over to u and du. No more x's. Once you make sure that you have the factors of du up there, you're going to rewrite the whole thing. When you rewrite it, look for the u first, because du has to be at the end. U is 3x to the 4th plus 4. You see it in there? So what am I going to replace this with? Well, I'm converting it over to u. Yeah, this is u to the 4th. Okay? Now I still have to convert over the 12 times the x cubed times the dx. What does that equal? Du. See, we already set it up that we're going to have the du. Now we have a nice, easy integration problem. Now we're going to use a power rule. We're going to add 1 to the exponent. So we have a 5 here. And then what do I multiply by? 1/5. So we've actually taken the antiderivative, and the only thing left to do is convert it back to x. So we switch it over to u so we can get the antiderivative. But once we have it, we write it back. So it's 2/5. And in for u, we put 3x to the 4th plus 4. So you pull any constant out, you assign u, get du, make sure you have all the factors of du in there, convert it over, take the antiderivative, and convert it back. Got another problem we want to do? 3. She still wants to do 3, kids. We're doing 3. Oh. Okay, number 3. What should I do first? Let's pull that 32 out of there. So we have 32 times the antiderivative. Oh, does anyone else want to see number 3? Yeah. The negative 5. And wait, in this one? Oh, number 9. They want to do 9? Let's do 9. I don't know. I'm trying to keep up with these kids.
I realized that
Maybe one you copied off the other. Okay. All right. First step, number 9. What constant can we pull out? Negative 5 out. I would, right? Don't forget that. So we have negative 5 times the antiderivative of secant squared. They don't, in this program, they don't put parentheses around the angles, but I like that. Over tan. When you look at, I know a lot of you freak out when you see trig functions and you shut down, but don't. When you look at them, say, hey, well, these guys, which guy's the function, which is the derivative? Because whoever the function is, that's your u. So that's why you have to know your derivatives well. So when you look at this, which one is the function? Tan is the function, secant squared is the derivative, right? Secant squared is the, so that's why you want to make the tan of 5x the u. Here. So u equals tan of 5x. If you made secant squared of 5x u, then the derivative would be 2 secant of 5x tan. It would be a big mess. You wouldn't have it. Okay, now remember your chain rule. What is du? The derivative. Okay, so it's the secant squared of 5x times 5. We could put that in front, right? The derivative of the inside, so you take the derivative of the outer function, secant squared of 5x times 5, and then we have the dx. Now you have to make sure that all the factors of what are there? U or du? Du, okay? So we ought to have all 3 of those there. Are we missing anything? The 5. So you could either put this one back. I'm not even going to do that ever. I'm just going to put in what I need. It wasn't there before, so what do I have to do? Divide on the outside by it. Okay, so what number do I have on the outside? Negative 1. Now I need you to convert this to u and du. Find the u first. Tell me where it is. Bottom. So down here, that's u. And what is the 5 secant squared 5x times dx all equal to? Du, right? We made it that way. Ooh. Now you got to know your formulas, your integration formulas. All right, Jillian. Yeah. The antiderivative of du over u is natural log of the absolute value of u. Then what? Yeah, plug the u back in, tan of 5x. So we have minus the ln absolute value of tan of 5x plus c. Oh, now,
Can't see.
come on, let's go back to 3. All right, kids, we're going back. Does anyone need this anymore? Yeah? Why doesn't this erase? It's not doing my. I'm going to leave that because she has to go back to 3. Maybe a couple.
Good.
All right. All right, so now we're going back to 3. Yeah. Now you're going to have to look at this because you wanted to see this. Yeah, that's why I'm putting it. So that's why you're going to be forced to look at it. I know, because I know normally you would just look away when you see that. All right, so what do we do first? Fill out the 32. 32 times the antiderivative. X cubed times 2x to the 4th minus 5. Oh no, to the 5/3. It's hard to see that with all this sticks. All right, now, so we pulled out the constant. Let's figure out who gets to play the role of u. What do you think? Yep. So u equals 2x to the 4th minus 5. So what is du? Take the derivatives, get du. Okay. Let's make sure we got them. We got to have the 8, the x cubed, the x. We missing anything? The 8. Put it in anywhere you want between. I'm putting it right there. So on the outside, 1/8. Time to convert. What's the coefficient? What's the number out front? Now when we rewrite it, save the du for the end. Du is the dessert. Yeah, I like that. All right, so the dessert. Save it for the end. All right, so what do we have when we rewrite this? U to the 5/3, and all that is just U. Good. Hopefully after you convert it to U's, it's something that it's like, I can do this. So we're going to use the power rule. Put it right smaller. Let's first add 1 to the exponent. 5/3 plus 1, 8/3. 5/3 plus 3/3 is 8/3. And then, so what do we have to multiply by? 3/8. The power rule, you add 1 to the exponent, then you got to multiply by the reciprocal of that new exponent. I have nowhere to go here. Now, if you multiply 4 over 1 times 3/8, what do you get? You get 12/8, that's true. For 3/2, right? Because 4 goes into 4 once and then twice. So we get 3/2. Where am I going? I guess that's over here. 3/2. Now it's u to the 8/3, but we'll just put that in there, right? X to the 4th plus 5 plus c. Ooh, I gotta start new stuff. All right. All right, so I do have to start some new stuff, so I'll just do this. Okay, well, we're not doing anything really new today, but we're going to be using U sub with trig, and we've seen some already, like you guys were just doing. But sometimes with trig functions, U will just be the angle, and sometimes it'll be a function of the angle. Let's pick A or B, because I want to make sure I get to the good stuff today. Pick A or B, either one. B, okay. Any ideas what we can make U? Whoa. What's that? It's okay if you give a wrong answer, because then I'll show you what. You want the secant squared of 5x squared? All right, let me, and I'm not saying this is right, but you said the secant 5x squared, you want all this for your u, and, okay. Okay, let's say that's what you thought that you was a good choice for you, okay? Yeah, but we're not going to learn anything unless we, and actually, I don't like trig functions with exponents. Let me just rewrite it like this, okay? So this would mean, if this was our u, that what we would need for du, remember, du is your shopping list. You got to have it all there before you start baking. You're going to need a 2 times all this to the first, right? We got to, times secant of 5x squared, tan of 5x squared, times 10x. You see what? You have all this stuff that you're going to need, and it's not there. And the only thing I can put in there would be a number. Yeah. Okay, you're like, oh, you're trying to, very close. Okay, so this was not a good choice for you because we don't have all those other factors of du. It's too much. Okay, so what's our next choice for you? 5x squared. This is going to be more manageable, right? All right, what's du then? 10x dx. All right, let's look at the factors of du. Can we get these? Yeah, what's the only thing we're missing? The 10. See, that's okay. You're only allowed if you're missing a factor that's a constant to put it in. If I was missing the x, I could not do this problem. Okay? But I can put in the 10. I have to just go like this. I don't have enough room. Say I have the 10 here. What goes, oh, this y equals, I don't, it shouldn't be there. What goes in front? A 1/10. Let's rewrite this. So now we have 1/10 and convert it over. Always look for the u part first because the u has to go at the end. So when I rewrite this, this is the u in here. So what do I write? Oh, I don't want to just write u. What about this? Secant squared of u. Right? U is just the angle. We still have. And then what's the rest? The 10 times the x times the dx. That's du. See, Manny, this is where you were going with it. Alrighty. So, what is the antiderivative of secant squared u du? Tan u. You're welcome. I'll do that. All right. So, that's it. We just got to replace it. We get 1/10 the tan of 5x squared. And if you think about it, if you took the derivative of that, you'd be right back to where you started if you used the chain rule. All right, it's kind of like an almost like, I don't know. You like it or you don't like it? All right. Okay, how do you know what to make u? You're hoping, you kind of have to look ahead and hope, you're trying to figure out how to make it look like one of your integration formulas. What's that? So you're hoping that this is going to look like one of your integration formulas. You only have like 17 of them, not even that many. I mean, it's not really too many. And so if you come up with a u substitution, and first of all, you don't have all the factors of du there, then that's wrong, And when I look at the secant squared, that's like one of the integration formulas, right? That's why that pops out of you. You want this to be secant squared of u. And it comes with a lot of practice, too, and really knowing your derivatives. Okay, this one, I don't have a formula. Even if I made u 2x, do I have an integration formula, antiderivative of tan u du? No, that was not one of them. Remember we started class out with those integration formulas? That was not one. Oh well. What can we do? Any ideas? For tan, we even if we make u 2x, we'll just have tan u with 1/2 the integral of tan u du. We don't have an integration formula for that. Any ideas? Like I'm hearing something. I don't know. I'm just wishing. Nope, not skipping it. If that's what I'm hearing. Yeah. Woo! I don't know. Something different then. Yeah, tan of 2x is equal to the sine of 2x over the cosine of 2x. Oh no, Jan just made it worse. Thanks a lot, Jan. Oh, you made it worse. I think that was with the quiz. I think that was with the quiz. Ask me later.
Oh, it was.
Yeah. Yeah, that was when. Does anyone see anything now? Why this is a good thing? Yes, sir. Okay, like that's not a bad idea, but if you did that, you're going to have a u over du. Du is not allowed in the basement. Okay, I'll give you a chance to fix it. There you go. We're going to let u equal the cosine of 2x. Yeah, you'll never have du in the denominator. If you do that, you did something wrong. Break what up? What? That would be secant. All right, that would be something else we don't have a formula, integration formula for. No, this is going in a good direction because if when you get du, what do you get? Negative sine of 2x times 2. Now, guys, we need every one of these factors of du in there. Chain rule. Took the derivative of the outer function, left the inside alone. That's why it's negative sine of 2x times the derivative of the inside function. Chain rule. Okay, what are we missing? What factors of du? The negative 2, because you're missing, this just means negative 1 times, right? If you move things around, you're missing a negative 2. Okay, no problem. Put it in here. But if I put a negative 2 inside, it wasn't there before, what am I putting on the outside? Negative 1/2. The reciprocal of a negative number is still negative. All right, rewrite it. So we get negative 1/2 times the antiderivative of find the u first. Where's the u? It's on the bottom. That whole denominator is just u. What is that negative 2 sine 2x dx? That's the du. Okay. Should we bring the u up and make it u to the negative 1 du and try to use the power rule? No. This is the only power we can't use the power rule on, right? When it's negative 1, because you try adding 1, you get 0, you can't divide by 0. So this is just its own separate rule. What is the antiderivative of du over u? ln. Absolute value of u. Let's see. So we get negative 1/2, the ln, the absolute value of cosine of 2x. That's something you're going to have to remember. Anytime you have to integrate tan or cotan, you have to remember to rewrite it. And then it'll be an ln. No, we're not going to do d. But just tell me for d what your u would be. 6x squared. So if you want to try that one, you can, because then you'd only be missing a 12. Oh, and you take the, I just have to get to what I got to get to on the other stuff that's really cool. Okay, F. This is why we can't fool around in the beginning, because we got to get to this stuff. Every second. All right. Oh my gosh, look at F. Trig functions. Think in terms of derivatives. Who's the function, who's the derivative? Because the function guy, that's your u. Who gets to play the role of u today? Cotan, right? The derivative of cotan is negative cosecant squared. So u, yeah. So we're going to make u cotan x. What's du? All right. Let's look at those factors, shall we? We missing anything? Just a negative 1, right? Oops. Put it in here. We have to put a negative 1 on the outside. All right. Look at that. What does it look like when you rewrite it? Du over u to the half, right? It's du over the square root of u, which is u to the half. I'll write it like that first. How are we going to integrate this? Power rule, right? It's not u to the first down there, so it's not an ln. That's just negative the antiderivative of u to the negative 1/2 du. Only use power rule after you bring it up. What is the antiderivative of u to the negative 1/2? What's the new exponent? Let's do that first. 1/2, because negative 1/2 plus 1 is positive a half. Multiply by the reciprocal, 2. So over 1 is 2. So we get negative 2. U was times the square root of cotan of x plus c. Where is this coming from? The negative was out here, and then when we multiply by the reciprocal. Now, even though I'm not going to be able to really show you big examples, I have to show you these 3 tricky u's. These are the u's that are going to mess you up if you're not aware that they're out there. These guys. Over the years, I've found that kids always have problems when u is either radical x, 1 over x, or ln of x. And the reason is because du is a fraction. And I just want to show you what these are. What is the derivative of the square root of x? Think about x to the half. What would its derivative be? 1/2 x to the negative a half. If we write that as a fraction, that's 1 over 2 rad x, right? What's the derivative of 1 over x, or x to the negative 1? No, don't, you're going the wrong way. You can crash. Negative 1 over x squared. These I would memorize, because they come up a lot. What about the derivative of the ln of x? 1 over x. The reason these are really tricky is because sometimes you don't see the full thing, like the top will be covered up. And if you take a look at this one up here, looks crazy, right? In this case, u equals the square root of x. Do you remember what du was for that one? Before we see what we need, what I'm going to do is I'm just going to show you that you can break this up. I can make this cos rad x times 1 over rad x, because this is just over 1. Right. You see I'm allowed to break that up? All right, what do you need on the inside, just so you can, anyone see what you need for your factors of du? This is du. You need 2, but it's on the bottom. So what are you really putting in? A half. So you need a 2 on the outside. All right? Good, guys. So there are 16 problems on the worksheet. Try to get at least 10. If you get 16, that's awesome. But try to get at least 10 of them. And I'll fill this one in. Bye.
Following students to the nurse, please. Jordy Alfaro, Gabrielle Carson, Laura
Bye, guys. I'm just filling this one in.
Doyle, Timothy Jones, Thomas
And I'm just going to go right to the end here.
Dylan Sederi, to the nurse, please.
I can't do the clever ideas one. Um, yes. Oh, yeah, you can sit in the back. No one's in the back. Oops, I somehow messed this up. Oh, well. Yeah. All right, so this is done.